Welcome viewers, in this video we'll see the details about the arrays available in the C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, arrays. An array is a collection of data types, all of same type, accessed using common name. So the array is a collection of data with the same type of data, and we can access the data with the common name. We have one more topic available, structures, that is collection of different type of data. Array is the collection of same type of data. Right? In order to avoid the repeated names, variable name, we can have the common name with the same type of data. For that we are using the arrays, collection of same type of data. So there are two types available. First type is the single dimensional arrays. Single dimensional array means a list of item can be given one variable name using only one subscript. Only one subscript is available. That is, we'll see the syntax: data type, array name, size. Only one. This is called a subscript. Only one size is there. Right? So the example is integer mark 100. So the data type is integer. Then array name is mark. This 100 is the maximum number of elements in the array. So by using the mark variable, we can store 100 different mark of the students. Right? So no need to go mark 1, mark 2, mark 3, mark 4 like that 100. We can have only one name mark. Type integer. 100 means we can store in this mark variable name mark, we can store 100. The 100 marks can be stored in this. So another example, integer a of 5 equal to 25, set of 25, 30, 12, 18, 20. So this is one example, mark with 100 marks or can be stored. This is another example, the integer type is integer, the variable name is a. We can store up to maximum of 5 elements. These 5 elements are given here, right? So this is the data type, this is the variable name, maximum number of elements in the variable name. This is the elements. These are all the elements. Now how these elements are stored, what is the how to access this, how to differentiate these 5 elements. So this is available, how to differentiate these 5 elements. So this first element 25 is stored in a of 0. So this is the variable name, this is 0. Similarly 1, 2, 3, 4, 5. This is called array indices. Array indices means this differentiate where it is located. Location, memory location. First variable 25 stored in a of 0. Second variable 30 is stored in a of 1. Third variable 12 stored in a of 2. Fourth variable 18 stored in a of 3. Fifth variable 20 stored in a of 4. Right? So this is the variable name, this is the array element, this is the array indices where it is located. So there are max 5 elements are there. We start from 0, so it is going up to 4. 0, 1, 2, 3, 4. Now you can easily understand. These 5 elements having different, the locations are available. A is the common name. A of 0 means first element. A of 1 means second element. A of 2 means third element. A of 4 means fourth element. A of 4 means fifth element. So see this, by using the indices we can have different names for the different location for the given array. So you can easily access. If you want to access the third element, we can use A of 2. Right? So array, single dimensional array mean only one subscript. We can have n number of elements that is differentiated by this array indices. Right? Now we'll go to the second type, two-dimensional array. The second type is the two-dimensional array. We'll see the details about the two-dimensional array. Array have more than one subscript variable is called a multi-dimensional array. Earlier we have only one subscript, now more than one subscript. For example, we have two subscript, that is called a matrix. That is a row size and column size. Earlier we have only size of the array. 100, 5. This multi-dimensional means more than one subscript. Suppose we have two subscript means that is coming under matrix. Multi-dimensional array is called a matrix. The syntax is data type, array name, row size and column size. We have row and column. So that is coming under the matrix format. The example is integer a 3, 3. Row size is 3, column size is 3. So 3 into 3 means 9 elements are available. 21, 18, 45, 23, 17, 32, 14, 11 and 19. So the 9 elements are available, right? So multi-dimensional array, in that two subscripts are available means it is a matrix. We need to specify row size and column size. The example is available. There are 9 elements are available. How these 9 elements are stored? So first we have to go with the row, first row. First 3 elements stored in first row. Second 3 elements stored in second row. Third 3 elements are stored in third row. In that, this first row, these 3 elements are stored. This first element stored in first row, first column. First row, second column. First row, third column. Like that it will store, right? So we need to differentiate row as well as column. See here the 3 elements are 0, 0, 0, 1, 0, 2. So a variable name is a. This 0 refers first row. This 0, 1, 2 refers first column, second column, third column, right? So a0, 0 first element will be stored. First column, first row. a0, 1 first row, second column, 18. a0, 2 first row, second column, 45. Right? So 21, 18, 45 stored in the first row with the first column, second column and third column. Similarly, a10, now see this 0 become 1. That means it is a second row. All are second row. In that, first column, second column, third column. Right? a10 means a0, 23 is stored. Second row, first column. a11, in that 17 is stored. Second row, second column. a12, 32 is stored. Second row, third column. Now we go to the third row, a of 2. See, a of 0 means first row, a of 1 second row, a of 2 means third row. In that, first column, second column, third column. a of 2, 0, 14. Third row, first column, we are storing 14s. a21, third row, second column, we are storing 11. a of 2, third row, third column stored in 19, right? So in single dimensional array, it is stored 0, 1, 2, 3 like that. In two dimensional array, it is stored as 0, 0, 0, 1, 0, 2. That refers first row, first column, second column, third column. Similarly, we have second row, third row. Now we'll see in more detail how it is stored in a matrix format. So what we discussed is given in a matrix format. It is given in this matrix format. This is a row 1, row 2, row 3. Because it is start from 0, it is given as row 0, row 1, row 2. That is nothing but this is first row, second row, third row. Normally we start with 0. Similarly, this is the first column, second column, third column. That is column 0, column 1, column 2. Here also we start with 0. Right? So by this we can see 0, 0, column 0, row 0. So this is the first element, 21. 0, 1, first row, second column, 18. Then 0, 2, first row, third column, 45. Right? 0, 0, 0, 1, 0, 2 refers all are first row. In that, first column, second column, third column. 21, 18, 45 are stored. Now we'll go to the second row. This refers the second row. 1, 0. Second row, first column, 23 is stored. 1, 1. Second row, second column, 17 is stored. 1, 2. Second row, third column, 32 is stored. Now second row is completed. Now we'll go to the third row. In third row, 0, 2, 0. 2, 0 means third row, first column, 14 is stored. 2, 1. Third row, second column, 11 is stored. 2, 2. Third row, third column, 19 is stored. Right? So the numbers are stored as 21, 18, 45, 23, 17, 32, 14, 11, 19 in a matrix format. So this refers row, first row, second row, third row. This refers first column, second column, third column. So we can easily identify any element. For example, this one means 1, 1. 1, 1 means second row, second column. Right? So single dimensional array, we have only one indices. Right? 0, 1, 2. In matrix, multi-dimensional means we are considering the two subscript, that is row size, column size. By using that, we can frame the numbers in a matrix format. So by using this two-dimensional array, we can perform the matrix manipulation, matrix addition, matrix subtraction, multiplication. All the calculation related to matrix can be performed by two-dimensional array. In single-dimensional array, we can store the set of numbers, either student name, student mark, average mark, balance. The common data are we can store register number, roll number can be stored in single dimensional array. So in this video we discuss about the array available in the C programming language. We discuss what is mean by array, then two types of array, single dimensional array and multi-dimensional, that is two-dimensional array. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the program to display single dimensional array available in the C programming language. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, single dimensional array. You know that array is the collection of same type of data having the same name. The variable name is same. In that we can store the same type of data. Different type of data is available in the structures. Structure is a collection of different type of data. Array is the collection of same type of data having the same variable name. In that single dimensional array means set of elements, set of data. We have one more type, two-dimensional array, that is called a matrix format, that is coming under matrix. So we'll have the single dimensional array having this is the variable name. This is maximum number of elements in the array. So this is the array elements. A of 5. A is the array element. We can store 5 elements. These 5 elements are given here. 21, 16, 10, 100, 8. How these elements are stored? So this is stored in A of 0, A of 1, A of 2, A of 3, A of 4. All these having the same name, but this 0, 1, 2 varies. So this 0, 1, 2, 3 is nothing but a array indices. By using the array indices, we can differentiate the variable name. A of 0 means first element, A of 1 second element, A of 2 third element, A of 3 fourth element, A of 4 fifth element. Start from 0, so it is coming up to 4. So totally 5 elements. In this 21 is stored. In A of 0, we are storing 21. 16 stored in A of 1. 10 stored in A of 2. 100 stored in A of 3. 8 stored in A of 4. Right? So A of 5 is the array, single dimensional array. We can store 5 elements. These 5 elements are given here. How these 5 elements are stored, that also details are given. By using the indices, we can differentiate the location, memory location. A of 0, A of 1, A of 2, A of 3, A of 4. So for example, A of 2 means third element. A of 4 means fifth element. So by using the indices, we can clearly differentiate with the common name, only A. Now we'll go to the program. First we'll include the header file. Include stdio.h, that is standard input output header file. It is used for print of scanf. Also include conio.h, console input output header file. It is used for get ch and clear screen. Then we'll start the main program, void main. Open the braces. Right? Now the main program is opened. So first we need to declare the variable. Variable declare integer A of 100. Right? So in that earlier we have A of 5. We can declare n number of elements. In that we can store 5 elements. Right? This is the maximum number of elements in the array. We can use 5 or 10, up to 100 we can use, right? Array element is A. In order to go for a looping, in order to get the data or display the data, we need for loop, because we need to display 5 elements mean we need for loop. For that we are using the variable I. This n is nothing but how many elements we are going to use. This is the maximum number of elements in the array. This is how many elements we need. That is the choice of the user. User can enter 10 or 20 or 5 based on the choice, right? So this n should be less than 100, right? Up to 100 we can use. So that is the choice of the user. So variable name A, we can store 100 elements. For loop we are using I. For n number of elements, how many number of elements we need? N. Then clear screen. The previous outputs are cleared. Then we ask the user to enter the data, how many elements you are going to use, by using the printf. Printf, enter number of array elements. We are asking the user to enter the number of elements. So the user will enter the how many elements he need, he will enter. That is scanned by scanf statement. Scanf %d. %d refers integer type. And n means address of n. The number what be stored by the user will be stored in the memory location n. So first we are asking the user to how many elements, how many number of elements he will enter. So by using printf we are display this sentence. By using scanf we read the data what we entered by the user, that is stored in and n, address of n. Now we ask the user to array elements. Suppose the n is 5 means we need to read 5 elements. Again we are using the printf. Enter the array elements. We ask the user to enter the array elements. So earlier we have 5 elements are there. So here also we will consider n equal to 5 elements. Now we need to read the 5 elements entered by the user. Now we are asking the user to enter these 5 elements. So for that we need for loop. Right? 5 times we need to read the data. So we are using for I equal to 0, I less than n. Right? It will be executed up to n times. I plus plus. We already discussed the array indices is nothing but 0, 1, 2, 3, 4. So in the sequentially order we need to generate the array indices. So here automatically it will generate 0, first 0. I plus plus means 1, 2, 3. It will go up to n number, right? So 0 is the starting number of the array indices. It will go up to n. It will increment 1 by 1. For example, n equal to 5 means how it will execute? First 0, then 1. First 0, it will scan the data. Then it become 1, scan the data. 2, 3, 4. While coming 5, it is invalid. So it will go up to 4. 4 means 0 to 4 means 5 times this loop will be executed. So scanf %d ampersand and a of I, address of I. What is the value of I? Initially 0. So the user what we entered first number is stored in a of 0. Then incremented a of 1. Second element stored in a of 1. Third element stored in a of 2. Fourth element stored in a of 3. Fifth element stored in a of 4. While going to a of 5, this condition is wrong. We assume that n is 5. So this condition in the loop is terminated. So this loop will be executed 5 times. So the user will enter 5 element that is stored in this corresponding location, starting from a of 0 to a of 4. Now we got all the 4 elements, all the 5 elements that is stored in from a of 0 to a of 4. Now we can display this element. Our aim is to display the single dimensional array. So again, printf, the array elements are, in order to identify we are putting one sentence, array elements are /n refers, it will go to next line. After printing this, it will go to the next line. So while printing the data also we need one more for loop. For loop is needed. For I equal to 0, I less than n, I plus plus. While what we used in the scanf, same for loop also here also needed. Because we need to print the data one by one. That is 5 data we need to print. So earlier we have scanf, now printf. Printf %d /n. /n refers after printing one data, it will go to the next line. a of I. What is I value here? 0. So it will first it will print a of 0. So after increment it will print a of 1, 2, 3, 4 up to 4. A of 5 means is invalid, is a condition is false. So the loop is terminated. So it will display 5 datas, a of 0, 1, 2, 3, 4. That is 5 data it will display. While displaying one data, it will go to the next line, right? Here also it will go to the next line. After this, it will go to the next line. So the data are printed in the one by one, new lines. Then we can close this loop after get CS. In order to view the output, we are giving get CS. Until you enter, you can see the output. The display will be there. Once if we enter any character, the program will be terminated. If you are not use the, you cannot see the output. It will be terminated immediately. So here it will wait for one more character to read. Until that you can see the output. Now we'll see the output of this program. So what is the output? First we are asking enter the number of array elements. We asked in the user. So the user enters 5. After that we are asked the user to enter the array elements. So the user enters. So this is already we discussed in the example. So that we can take the same number 21, 16, 10, 100, 8. Right. So the user enters how many number? 5. These 5 numbers also entered by the user. So it is correspondingly stored in a of 0, a of 1, a of 2, a of 3, a of 4. Now we can display the number. The array elements are. So we use /n. So it will go to the next line. It will print the first number 21. There also we use the /n. So it will go to the next line. So next line, new line, it is printed. So array elements are 21, 16, 10, 100, 8. So this is the output of the program. First you will ask the array elements, how many elements. Then you will ask the array elements that are entered. These array elements are printed one by one. So in this program we discuss how to display the single dimensional array. We consider 5 elements. We saw discuss the program, how to read the program, how to display the array elements. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the program to display 2-dimensional array in the C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic. Program to display 2-dimensional array in a C programming language. We know that array is the collection of same type of data. Same type of data are arranged in the array. In that we have 2 types available, single dimensional array and 2-dimensional array. Single dimensional array means group of numbers, set of numbers, 10 numbers or 100 numbers. 2-dimensional array is the having 2 dimension, that is row and column. It is a matrix format. 2-dimensional array is nothing but a matrix, right? So you see that we have the A of 3, 3 equal to, there are 9 numbers are given. So the A is the array name. 3 indicates the row size and these 3 indicates the column size. These 9 numbers are indicate the matrix elements, array elements, right? So A 3 3 equal to 9 numbers given. It is nothing but a 3 cross 3 matrix. Now we'll see how these elements are arranged in the row and column. So there are 3 rows available. It is named as 0, 1, 2. Row 0, row 1, row 2. Always we start with 0. Row 0, row 1, row 2. Similarly column 0, column 1, column 2. Right. So the first number 3 is arranged here. That is A of 0, 0. That refers first column and first row and first column. This 0 refers the column. This is the row. That will refer the row size. This is the column, right? So 0 means 1. So first row, first column. The second number 5 is arranged in 0, 1. Same first row, second column. Third element 1 is arranged in the assigned in the A 0, 2. First row, third column, right? So 0, 0, 0, 1, 0, 2. This 0 indicates first row. This 0, 1, 2 mean first column, second column, third column. So after that we'll go to the second row, row 1. This number 4 is assigned here, A of 1, 0. Here 1, 1, 1, 2. So this 1 refers second row. All are available in the second row. In that, this is available in the first column, 8 available in the second column, 9 available in the third column. So 1, 0, 1, 1, 1, 2. That refers second row with column 1, 2, 3. Then we'll go to the third row. A 2, 0, 2, 0, 2, 0, 2, 1, 2, 2. So this first 2 refers the third row. This 0 refers first column, 1 refers second column, this 2 refers third column. Right? So like this the elements are arranged in a matrix format. 0, 0, 0, 1, 0, 2. 1, 0, 1, 1, 1, 2. 2, 0, 2, 1, 2, 2. Right? We will see the analysis. We will analyze this. So this number is nothing but a column index. It indicates column index. This number indicates row index. This is nothing but array name. This is nothing but a array element. Right? The 2 is the array element. A is the array name. 2 indicates row index. This one indicates column index. Right? So we are able to understand how this 3 cross 3 matrix, how the elements are assigned. What is the row index and column index is clearly given here. 0, 0, 0, 1, 0, 2. 1, 0, 1, 1, 1, 2. 2, 0, 2, 1, 2, 2. That is the assignment of 9 elements in a 3 cross 3 matrix. Now we'll go to the program. First we need to include the header files. The header files are included. Include standard io.h. stdio.h is nothing but standard input output. Here we are using printf and scanf. Then include conio.h, console input output.h header file. That is used for clear screen and getch. Right. Now we'll start the main program. Void main. Open the braces. So hereafter we can write the instruction codings. Right. The first step is we need to declare the variables. In this program we are going to display the 2-dimensional array. So we need to declare 2-dimensional array. A 10, 10. So this 10 indicates row size. This 10 indicates column size. Here when we are going to use only 3 cross 3 matrix, but while declaring we are declaring maximum value. This is the maximum number. We can use up to 10 row and 10 column, but we can use less than that also. Right? So 10 into 10, 100 memory location will be allocated. In that we are going to use only 3 into 3, 9 elements, but we can use 10 into 10, 100 also. Right? So we created the maximum rows and column. We can go for 100 also. Right? So we'll try to here, otherwise we can create A of 3, 3 also. What we required that also declared, but here declares 10, 10. Right? In order to assign the variable, we have 2 loops are needed. That is for loop. In that one more loop is needed. In order to vary the row, one loop is needed. In order to vary the column, one more loop is needed inside. So that we are declare I, j for creating the loop. This m, n refer the row size, n refer the column size. Right? So we need to get the row size and column size from the user. So that we are declare 2 more variable mn. M we are assign row size, n will assign column size. So this is the maximum number of column, maximum number of row, maximum number of column. This is the row and column entered by the user, m and n, number of row and number of column. Right? Now we'll clear the screen in order to clear the previous program. Now we'll get the input from the user. First we are printf enter number of rows and columns. We ask the user to enter the how many rows and column we are going to use. Scanf %d and m and n. This scanf is used to read the data entered by the user. This %d indicates integer type. We are going to get row and column, 2 elements. So that %d 2 times. Then first one is the row size. Row size is stored in M. And M in address of M, memory location. And N indicates column, number of column. And N refers address of N, right? Now the user enter two values that is stored in M and N. Let us consider M is, the user enters 3 and N is entered as 3, because we discussed earlier 3 cross 3 matrix. So here also we assume that M is 3 and N is 3 entered by the user. Now we ask the user to array elements. 3 into 3, 9 elements we need to enter. We need to get from the user. Printf enter the elements of matrix. We ask the user to enter the elements of the matrix. So the user will enter 9 elements, right? 3 cross 3, 9 elements will be entered by the user, right? How that elements are stored? See this, we have one for loop is available. For I equal to 0, I less than M, I plus plus. We already know that I what we entered is 3. We entered as 3. So this will vary 0. Then I plus plus means 1. Then I plus means 2. Then 3. 3 is invalid. It will go up to 2. So I will vary first 0. After executing, it will incremented to 1. I plus plus. After that, it will incremented to 2. Then it will incremented to 3. But 3 is not a valid condition. I less than 3. Less than or equal to means valid. Less than 3. Less than 3 means 2 only. So here the I will vary 0, then 1, then 2. If it is 3, it will be terminated. So inside we have one more loop is available. We have one more loop for J loop. So J equal to 0. Here also we already assume that the N is nothing but 3. Right? So here J will be first 0. It will execute. Thereafter incremented. J plus plus means it become 1. Then again incremented. Then it become 2. While it is 3, it will be terminated, right? So this for loop also, the J loop also executed 3 times. Then it will go to the main loop, right? So the outer loop, first J equal to 0, it will come inside. I equal to 0, it will come inside. J will be 0, 1, 2. Then it will go to the outer loop. Like that it will go, right? How it is varied? I, J. So I is initially 0. The condition is true. So it will go to the inner loop. Inner loop, what will happen? First J equal to 0, then 1, then 2. For the cases I equal to 0 only, right? For J equal to 0, then in 1, 2. 3 means it is invalid, right? So I equal to 0, J equal to 0. I equal to 0, J equal to 1. I equal to 0, J equal to 2. So user what we entered, first number will be stored in 0, 0. Second number stored in 0, 1. Third number stored in 0, 2. So this is what we discussed earlier, right? So this 0 indicates first row. This 0, 1, 2 indicates first column, second column, third column. So the first element stored in the first row, first column, first row, second column, first row, third column. Here 3 means the condition is valid. So it will go to the outer loop. Outer loop again the I is incremented 1. It will go to the inner loop. Inner loop again it will be executed 0, 1, 2. 3 means terminated. So in these two cases also J equal to I equal to 1 only. So 1, 0, 1, 1, 1, 2, right? The third element will be stored in 1, 0. Fourth element stored in 1, 1. Fifth element, sixth element stored in the 1, 2, right? Fourth element, fifth element, sixth element. That indicate what is that? This one indicates second row. Second row, first column, second row, second column, second row, third column, right? So it is 3 means terminated. So it will go to the outer loop. Outer loop it will be incremented. I is incremented to 2, right? For these two again inner loop is executed again 0, 1, 2. 3 means terminated. Here also 3 means terminated. See this, the 7th element stored in 2, 0. 8th element stored in 2, 1. 9th element stored in 2, 2. What does that indicate? These two indicates third row. This 0, 1, 2 indicates first column, second column, third column, right? The user what entered 9 elements are arranged in this order 0, 0, 0, 1, 0, 2. First row 3 column 1, 0, 1, 1, 1, 2. Second row 3 columns 2, 0, 2, 1, 2, 2. Third row 3 columns. So this only what we discussed in the earlier, right? So percentage D and A of I, j. So this I is 0, then 0, 0, 1. Like that it will vary. So the corresponding elements are stored arranged in this order. So there is nothing but matrix element. So now we received all 9 elements from the user that is stored in this corresponding locations. Now what is the next step? We need to display the matrix. So the program is displayed, right? So same for loop we need to repeat. Here scanf, we read the data. Now printf, we need to print the data. Printf the given matrix is. This /n indicates after printing this it will go to the next line. The matrix will be printed in the next line, right? Again here also we need to open two loops, outer loop and inner loop. How we read the data in this order? The same order we need to print the data. I equal to 0, I less than m, I plus plus. Then open brace, inner loop, j equal to 0, j less than n, j plus plus. We already know that this is 3, this is also 3. Then it will print percentage %d. First element is 0, 0 will be printed. /t refers between the first element and second element, tapping is there. Some space will be provided. So first it will print the first element, second element with the tab, third element. So this will be completed. So the row 1 will be printed. 0, 0, 0, 1, 1, 0, 2 will be printed. After 2, this inner loop is terminated. So it will go to the outer loop. Outer loop what we have? Printf /n. So it will go to the next line. After printing the first row, the second row is go to next line. So that it will be available in the, it will display in a matrix format. Then it will go to the outer loop. Now I equal to 1. Then it will come inside. Again inner loop will be executed. 1, 0, 1, 1, 1, 2 with the tabbing. Then it will go to the outer loop, next line, third row. Then it will go to the outer loop. I equal to 2, 2, 0, 2, 1, 2, 2. With the tapping, it will display. Then it will go to the next line. So all 3 rows are displayed. Now we'll see the output of this program. So after displayed, get cgets. In order to see the output, we have get cgets. So after entering the one character, the program will be terminated. Until that, it will wait for getting the character. At that time, we can see the output. Then close the braces. So what is the output here? But first we ask, enter the number of rows and columns from the user. User enters 3, 3. This is nothing but m, this is n. 3 is stored in m, this 3 is stored in n. Then we ask the enter, user to enter the elements of array. What we discussed in the same elements. 3, 5, 1, 4, 8, 9, 3, 2, 7. These 9 elements are entered by the user. If suppose the user enter more than 9, that will be invalid. This program will read only 9 elements. The user entered by more than 9 elements. After the 9th element, that will not be stored. Right. So with the output, we display that the given matrix is. We display the first row. 3, 5, 1. This is the tapping. Between first element, second and third element, tapping is there. After printed the first row, we go to the next line. Printf /n. So he printed the second row with the tapping. Then it will go to the next line. So the third row will be printed with the tapping. Right. So now it is in a matrix format. 0, 0, 0, 1, 0, 2. 1, 0, 1, 1, 1, 2. 2, 0, 2, 1, 2, 2. Right. So this is the program to display the matrix. So in this program, we discuss how to get the matrix from the user and how to display and what is the arrangement of matrix, how the elements are stored in a matrix, the array index and column index we analyzed. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the program to perform the matrix addition. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Program to perform matrix addition using C programming language. So this matrix addition we can perform using the array. We know that array there are 2 types available, single dimensional array and 2-dimensional array. Array is nothing but collection of same type of data. Single dimensional array means set of datas. Two-dimensional array means it refers the matrix. It refers row size and column size. So in order to perform matrix addition, we need to use the two-dimensional array. Now we'll see the matrix details. Dimension of the first matrix, m1 into n1. That is nothing but m1 is the row size, n1 is the column size. Similarly, dimension of the second matrix, m2 into n2. m2 is the row size, n2 is column size. Right? So we have two matrix, m1 into n1, m2 into n2. In order to perform the addition, what is the condition? We need to check the condition. The row size of first matrix m1 is equal to row size of second matrix. m1 should be equal to m2 because the rows and columns only the corresponding elements we are going to add. So the number of rows in both the matrix should be equal. Similarly, number of column also should be equal. n1 equal to n2. Right? Number of rows in first matrix and second matrix should be equal. Number of column in first matrix and second matrix should be equal. So while adding, what is the resultant matrix? What is the dimension of the resultant matrix? It may be m1 into n1 or m2 into n2 because both m1 m2 are equal. Right? So all the matrices are having same dimension. m1, n1, m2, n2. The resultant may be n1 into n1 or m2 into n2. Right? Let us consider the 3 cross 3 matrix. Suppose the dimension of first matrix is 3 cross 3 mean second matrix also 3 cross 3, resultant matrix the also 3 cross 3. Right? So the size of first matrix, second matrix and resultant matrix are equal. Let us consider in this entire program we are using 3 cross 3 matrix. Let us consider this is the first matrix A. We are having this matrix elements 3, 6, 7, 2, 1, 4, 5, 8, 2. So this is the first row, second row, third row. First column, second column, third column. How it is located is given here. First matrix located at 0, 0, the second one. Then 0, 1, 0, 2. This 0 refers first row. This 0 refers first column. This 1 refers second column. This 2 refers third column. Similarly, we have second row and third row. 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So according to this location, the elements are stored in the memory location, in this memory. Right? This is the first matrix. Similarly, the second matrix B. 1, 2, 4, 6, 7, 9, 3, 1, 4. So this is also stored in B of 0, 0, B of 0, 1, B of 0, 2. Like that it will store. Here A of 0, 0. Right. So now we have 3 cross 3 matrix, first matrix A, 3 cross 3 matrix, second matrix B. This is the location. Now we need to perform the addition. We need to add first matrix and second matrix. Right. What is the procedure to add the matrix addition? The element, first element 0, 0, A of 0, 0 should be added with B of 0, 0. A of 0, 1 should be added with B of 0, 1. The corresponding elements are added together. That is 3 plus 1, 6 plus 2, 7 plus 4, then 2 plus 6, 1 plus 7, 4 plus 9, 5 plus 3, 8 plus 1 and 2 plus 4. Right? The corresponding locations are added. After adding what we got? 4, 8, 11, 8, 8, 13, 8, 9, 6. So this is nothing but C of 0, 0, C of 0, 1, C of 0, 2. Right? So corresponding location, corresponding matrix, first matrix, A matrix and B matrix are added. Corresponding elements are added together. Right? So then what is the expression? We need to give the general expression. That is C of 0, 0 is nothing but, that is the first element is nothing but A of 0, 0 plus B of 0, 0. A of 0, 0 is added with B of 0, 0. That is nothing but C of 0, 0. Similarly, C of 0, 1 is nothing but A of 0, 1 plus B of 0, 1. Like that we can add. So in generally how we can write? C of I comma ij equal to A of ij plus B of ij. Right? This I and j is we are using in the for loop. For example, I is the outer loop. Here 3 cross 3 matrix. So we need to vary from 0, 1, 2 like this. 0, 1, 2. Similarly, j used for column matrix. There are 3 columns available. 0, 1, 2. Like that we can vary. So automatically while using the for loop, this sentence, this statement will be automatically generated for 0, 0, 0, 1, 1, 0. Like that it will be automatically generated. So the general expression is C of ij equal to A of ij plus B of ij. Right. Now we'll go to the program. So in the program, first we'll include the header file std include stdio.h, that is standard input output dot header file. It is used for printf and scanf. Then include conio.h, console input output dot header file, used for get ch and clear screen. Then we can start the main program, void main, open the brace, right? That means the instructions are going to start. First we need to declare the variables. So what we have, first matrix A, second matrix B, resultant matrix C, right? Here we declare A of 10, 10, B of 10, 10, C of 10, 10. So this is the maximum size of row and column. Entire program we are going to use 3 cross 3 matrix. So this is the maximum location. 10 into 10 means 100 memory location will be allotted. In that we are going to use 3 cross 3, 9 elements. Otherwise we can directly use A of 3, 3 also. This is generally we declared with 10 elements. This is the number of rows and columns, M1, M2, N1, N2. This is the row size of first matrix and second matrix. N1, N2, column size of first matrix and second matrix. We already discussed we need a for loop is needed. 2 loops are needed in order to vary the row and column. So we can declare 2 variable I comma j, right? So the first matrix, second matrix, resultant matrix, row size, column size, and variable for loop. Right. After clear screen, first we need to get the detail from the user. Enter the number of rows and columns of first matrix. We are asking the user to enter the column, first row, number of rows and column in the first matrix. So the user will enter 2 data. That is scanned by this scanf, %d, that refers integer type, and M1 and N1. This is row size, this is column size, M1 and N1. Then we ask the user to enter the rows and columns of second matrix. Then user will enter 2 data and M2 and N2, and refers the address. So user will enter another two data, row and column, M2, N2. Right. Now we got the number of rows and columns of first matrix as well as second matrix. Now we need to check the condition whether it is possible to make the matrix addition. We need to check the condition. What is the condition? If M1 equal to double equal mean it will check both are equal. Similarly N1 double equal to N2, which is the checking conditional operator, right? Whether it will check both the conditions should be true, then only we can proceed. So that we are using AND symbol. So AND logic is nothing but if both the conditions are true, then only it will return 1. If any one condition is 0, it will return 0 only. Right. So M1 is M2. It will check M1 is equal to M2. If both are equal, it will return 1. N1 is equal to N2. If both are equal, return 1. 1 and 1, it will return totally 1. If any one condition is false, it will return 0. Right. Then it will go to the else part. This is the if part. So if both the conditions are true, it will go inside. Here one brace, we open one brace, right? What we need, so we can perform the matrix addition. Now we need to ask the user to enter the elements of first matrix. Printf, enter the elements of first matrix, right? Matrix. So we already discussed 3 cross 3 matrix. So user will enter 9 elements. The first element should be stored in 0, 0, then 0, 1, 0, 2. For that we are using one for loop. For I equal to 0, I less than M1, I plus plus. We already decided that this M1 value is 3, this N1 value also 3. Right. So first we open the outer loop, I equal to 0, I less than 3, I plus plus. So initially the I value is 0. Right. Then it will go to the inside. Inside we have another loop, j equal to 0, j less than 3, j plus plus. So now j also 0. Now user will enter one data that is stored in a of 0, 0. Right. Then it will go to the I j plus plus. So j1 become 1. The I is again 0 only. So the user will enter the second data that will be stored in 0, 1. Then I is j is incremented to 0, 2 and I is 0 only. So the third element will be stored in 0, 2. Now when the j become 3, it is terminated. It should be less than 3. J should be less than 3. Then only the loop will be executed. Now it is equal to 3. This is terminated. Right? Inner loop is terminated. Now we'll go to the outer loop. Again, now ji become 1. So I plus plus is there. So I become 1. Again this j is repeated. 0, 1, 2. That is 1, 0, 1, 1, 1, 2 it will store. Again it is terminated. Go to the outer loop. The I become 2. Then it become 0, 1, 2, j, 2, 2. So the another 3 elements stored in 2, 0, 2, 1, 2, 2. Right? If the I is 3, the loop is terminated. Right? So we are using inner and outer loop. Inner loop used to vary the column. Outer loop used to vary the row size 0, 1, 2. Right? So the user enter 9 elements. These 9 elements are correspondingly stored in the A of 0, 0 to A of 2, 2. Right? All the values are stored. The same process now it is closed. Inner loop and outer loop. The same process repeated for the second matrix. We need to repeat for the second matrix. Enter the elements of second matrix. Same thing. Here M2 and N2. Anyway, M1 is equal to M2, N1 equal to N2. N1, M1 also we can use. Both are equal. It is stored in B of Ij. Right? Second matrix is stored in B of Ij. The same process 0, 0, 0, 1. Now we got the first matrix and second matrix from the user. Now we can add the two matrix and store the result in matrix C. Now we'll see how to add the matrix. So while adding also we need this for loop because correspondingly we need to store A of 0, 0 should be added with B of 0, 0 that is stored in C of 0, 0. The same matrix, same loop we are opening. Outer loop and inner loop. M1 and N1 we are using. M2 and N2 also we can use because both the conditions are equal. Correct. M1 equal to M2, N1 equal to N2. So this loop will vary. First it will vary I equal to 0 and j equal to 0. So A of 0, 0 and B of 0, 0 are added. That is stored in C of 0, 0. Then j become 1. I is again 0 only. So A of 0, 1 is added with B of 0, 1 that is stored in C of 0, 1. So it will go up to the all 9 elements it will be added. The resultant addition of two matrices is available in the variable C. Right? Now this matrix we need to display. We need to display the resultant matrix. Right? In order to display the answer we need to go for another two loops. The resultant additional matrix is this slash n refers it will go to next line. After printing this sentence it will go to next line. So here also we need to open two matrix. Two loops we need to open. So while scanning the first matrix we need two loop. While scanning matrix B again we need two loops, same loop. Then while adding also we need, while display the result also we need the same loop. Here M1, N1. You can use M2, N2 also. Right? So this print of slash n it will go to the next line. Here it will print the C of 0, 0. We are using slash T. After print the first element the tapping will be given. Some space will be given. Right. After printing this first row it will go to the terminate. This loop is terminated. Here slash n. So the second row will be printed in the next line. This loop will print the row. After printing it will go to second line. So the next row will be printed in new line. Right. So that we can close the process. Suppose if the condition is not correct. If the condition is not, it will go to else for. What we need to print? Matrix addition is not possible because row and column size are not equal. Right? If it is equal, we can process this. Otherwise, we can print get the addition matrix is not possible. Then get ch, we can close the program. This get ch is used to wait for, we can see the output until we are giving one character, it will wait so that we can view the output. Right. Now we'll see the output for this program. What is the output we got? There are two cases available. One is the matrix addition is possible. Another one is matrix addition is not possible. First you will see the possible. Enter number of rows and column of first matrix. So user entered 3 3. Enter number of rows and columns of second matrix, that also 3 3. Right. Now enter the elements of first matrix. What we discussed in the example, same elements 3 6 7 like that. Then enter the elements of second matrix 1 2 4 matrix B. So this will be added, the resultant will be 8 4 8 11 8 8 13 8 9 6. What we discussed in the example, the same values, right? So this is one possible output. Another possible output is the addition of matrix is not possible. Now we'll see the second type of output. So the second possible of output here, we ask the user to enter the number of rows and column 3 3. Enter the number of rows and columns of second matrix. What we entered is 2 2, right? So these two are not equal. The number of rows in first matrix is not equal to second matrix. Similarly, column also not equal. We cannot perform because both should be equal. Then only we can add the relevant elements, right? So this is 3 cross 3 matrix. This is 2 cross 2 matrix. So it will go to the else part. There we display matrix addition is not possible, right? So this is the another possibility of output. First one is normal output, possible output. So that added and the resultant matrix is displayed. This is matrix addition is not possible. So in this video we discuss how to perform the matrix addition using C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the program to perform matrix subtraction using C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic, program to perform matrix subtraction. So this matrix subtraction, this matrix is given by array. There are two type of array available, single dimensional array and two dimensional array. Single dimensional array is a collection of numbers, collection of data. Two dimensional array refers the matrix, row size and column size, right? The same type of data is contained in the array, different type of data means structure, right? So here we need a two dimensional array in order to perform the matrix subtraction. So in this we need to see the dimension of the first matrix, second matrix and resultant matrix. That is the important. First you will see the dimension of the first matrix, m1 into n1. That is nothing but number of rows is m1, number of column is n1 for the first matrix. The second matrix m2 into n2. Number of row is m2, number of column is n2. Right. In order to perform the subtraction, we need a condition is available. The condition is there. What is the condition? The row size of first matrix is equal to second matrix. m1 is equal to m2. Similarly, n1 equal to n2. Number of column in the first matrix should be equal to second matrix. Then only we can perform the matrix subtraction. So based on that, the resultant matrix may be m1 into n1 or m2 into n2 because all the dimensions are same. Dimension of first matrix, second matrix, resultant matrix are equal. Then only we can perform the subtraction. So the resultant matrix may be m1 into n1 or m2 into n2. Right. Now we'll see the how to do the matrix subtraction. So let us consider the 3 cross 3 matrix. The entire program will follow the 3 cross 3 matrix. This A is the first matrix having 3 cross 3. The 3 rows and 3 columns are available, and B also 3 cross 3 matrix, right? So these are all the elements available, 8 6 9 7 5 4 6 9 5. Similarly matrix B, how it is located? So this location is given here, right? This is the first row, second row, third row, first column, second column, third column. 0 0 refers the first element, first column, first row, first column. 0 1 refers the first row, second column. 0 2 refers the first row, third column. So this zeros refers column, first row. This 0 1 2 refers first column, second column, third column, right? So like that we have 1 0 1 1 1 2 2 0, 2 1, 2 2. These are all the location of the matrix, right? So here it is given A 0 0 because of matrix A 0 0. In case of matrix B, it is given B 0 0, right? Then how to add this matrix? The C is the resultant matrix. How to subtract this matrix? The A 0 0 is minus B 0 0. The 8 minus 6. The corresponding locations are subtracted, right? The element available in 0 0 of A matrix, the element available in 0 0 of B matrix is subtracted. 8 minus 6. Similarly, 6 minus 4, 9 minus 8, 7 minus 5, 5 minus 4, 4 minus 2, 6 minus 5, 9 minus 3, 5 minus 1. So this is the subtraction. The corresponding locations are subtracted. So the resultant will be this matrix 2, 2, 1, 2, 1, 2, 1, 6, 4. So this is also same location. This is C of 0, 0. This is C of 0, 1, C of 0, 2. Right? Like that we can frame the matrix C subtraction. Right? So how to frame the general equation, general expression. So how we are adding A of 0, 0 minus B of 0, 0, 0. That resultant is stored in C of 0, 0. Similarly, C of 0, 1 is nothing but A of 0, 1 minus B of 0, 1. Like that we can do the subtraction. Right. So generally we can write. So finally C of 0, 0, C of 2, 2 equal to A of 2, 2 minus B of 2. Right. So this can be written as C of ij equal to A of ij minus B of ij. So what is this ij? By using for loop, because here we need to create the number 0, 0, 0, 1, 0, 2 like that. For that we need here 2 loops are needed. 2-dimensional array means 2 loops are needed, one for row, another for column, right? So here this refers the row, this one refers the column, right? So that is applicable for all three matrix, right? So C of ij equal to A of ij minus B of ij. So this is the general expression. During the program we'll see what is the value of I and j. Now we'll go to the program. First we'll include the header files. Has include standardio.h, stdio.h. This is used for printf and scanf. Then hash include conio.h, console input output dot header file. It is used for clear screen and get cgh. Then we'll start the main program. Void main, open the brace. The first next step is we need to declare the variables. What are the variables we need? We need to declare, right? So first we will declare the matrix A. This is matrix A, first matrix. B is the second matrix. C is the resultant matrix, subtraction matrix. This M1, N1 is the dimension of first matrix. M2, N2 is the dimension of second matrix. This ij used for loop, right? So first matrix, second matrix, resultant matrix, dimension of first matrix, dimension of second matrix, and variable used for loop. So after declaring the variable, we can go for clear the screen in order to clear the previous content. Then we need to get the row size and column size of first matrix and second matrix. So we need to print out. Enter the number of rows and column of first matrix. We are asking the user to enter the row and column size of first matrix. So the user will enter two data, row size and column size. That is scanned by scanf. Scanf %d and M1 and N1. This %d refers the integer type data and refers address of M1, address of N1. So the user what the data enter, two data are stored in M1 and N1. Then printf enter the number of rows and column of second matrix. We asked to enter the row and column size of second matrix. Scanf %d and M2 and N2. So this is the row size of second matrix and row size of column size of the second matrix, right? Now we got the dimension of first matrix and second matrix. Now we need to check the condition. The condition is available. We need to verify whether we are able to do the matrix subtraction for the given row size and column size of matrix 1 and matrix 2. for that we are going for if condition. If m1 double equal to m2, this is called here is checking whether both are equal, right? And symbol n1 double equal to n2. So m1 equal to m2 mean assignment operator. This is a equal to operator, whether both are equal. m1 is equal to m2. Both are equal mean it will give the value 1. Not equal means 0. Similarly n1 and n2. Then and symbol used for a logical operator. If both the input, both the conditions are true, then only it will return 1. Any one condition is 0 mean it will return 0, right? So we need two conditions. The rows should be equal and columns should be equal. If it is true, both are equal means we can go for the matrix addition, matrix subtraction, right? Before that we need to get the elements of the first matrix. Printf enter the elements of first matrix. We ask the user to enter the elements of the first matrix, right? So the user will enter 3 cross 3 9 elements. We assume that we are using 3 cross 3 matrix for this entire program. So the first element should be stored in 0 0, second will store in 0 1. So for that case we are open the for loop. For I equal to 0, I less than m1, I plus plus. We assume that m1 value is 3. n1 value also 3, right? So what will happen here? I will be 0. I value will be 0. Then condition is correct. So it will go to the next loop. Here inside we have one more loop. Inner loop is available. J equal to 0, j less than n1. This column size. So this condition also correct. So the j value will be 0, right? So user what enter the first data will be stored in 0 0. That is scan of %d address of A. I is 0, j also 0. So it will be stored in A of 0 0, first element. Thereafter the j is incremented. It's an inner loop. It will complete the inner loop, then it will go to the outer loop. So inner loop, the j value is incremented to 1. I value is remain 0. So the next element stored in 0 1. Then j value incremented to 2. I value remains 0. The third element stored in 0 2. Right. When the j is 3, the condition is false. So it will go to the outer loop. It will terminate the inner loop and go to the outer loop. In that outer loop, now the I become 1. Because of I plus plus, I become 1. Then again j will start 0, 1, 2. In that case, I is 1. So it will store in 1, 0, 1, 1, 1, 2. Like that, it will store all the 9 elements. We assume that 3 cross 3 matrix, right? So based on the for loop, outer loop and inner loop, automatically what the user will enter, the data are stored in first matrix. Similarly, we need to get the elements of the second matrix. Same thing, we need to open again for loop. Here m2, n2 because of second matrix. But anyway, m1 equal to m2, n1 equal to n2 also. Here and of b of ij, right? Second matrix. So the user will enter 9 elements. All these 9 elements are stored in b of 0, 0, 0, 1, 0, 2 like that. Now we got the matrix A and matrix B, first matrix and second matrix. Now we need to subtract this matrix. We'll go for the subtraction. So for subtraction also we need to open another 2 for loop because the corresponding locations are stored. We need to perform A of 0, 0 minus B of 0, 0, that should be stored in C of 0, 0. So we are opening the 2 for loop. This will for row, this is for column, right? Again m1 and n1 is used. We can use m2, n2 also, right? So what happened? A of 0, 0 minus B of 0, 0 will stored in C of 0, 0. Then A of 0, 1 minus B of 0, 1 will stored in C of 0, 1. Like that, it will subtract all 9 elements. Now the resultant matrix, subtraction matrix is available in the matrix C. Now we need to print the resultant matrix. Now we'll go for the printing of the resultant matrix. So print of the resultant subtraction matrix is /n. What is this /n? After printing, it will go to the next line. So while printing also we need to open 2 for loops. Here m1 and n1 is used. So first is 0, 0. Print of %d /t. What is this? After printing the first element, the tapping will be given. Some space will be given. So it will print C of 0, 0. Then it will go to 0, 1, 0, 2. With the tapping, it will print. So after completing one row, it will go to the, this loop is terminated. Here what we have /n, so that it will go to the next line. Next row will be printed in next line. Then it will go to the incremented. So the second row elements are printed with tapping. Again it is go to the new line. So the all 9 elements are printed in a matrix format. Because of this /t tapping and next line, it is printed in a matrix format. Then we can close the loop, right? These two, this for loop is closed here, this for loop is closed here. This is for if condition. The condition is satisfied, then only we open the brace. Here it is closed. Suppose if it is else, the condition is not correct. What happened? We need to print the message. Print of matrix subtraction is not possible. Then close the brace and get ch and close the program. Get ch is used to get the character. Until that we can see the program, output of the program, right? So matrix subtraction not possible, we closed. Now we'll see the output of this program. There are two possible outputs. One is matrix addition is possible, another one matrix addition not possible. We'll see both the cases. So output 1. First what we are doing, we enter the number of rows and column of first matrix. So user will enter 2 value, 3, 3. We assume that we are using 3 cross 3 matrix. Enter the number of rows and columns of second matrix, that also 3, 3. See, now the condition is correct. Number of rows in first two and second matrix, column in first and second matrix are equal. Then enter the elements of the first matrix. So the same value what we are using in the example, the same values are entered, 9 values. If we enter 10th value, not a problem. It will not accept. It will not store in that location. Only it will accept 9 values. Then enter the elements of the second matrix. So the elements are entered. Now it will add both the all the data, it will be subtracted. Then we'll go to the resultant. See how the resultant matrix is printed, subtraction matrix. So the resultant subtraction matrix is 2, 2, 1, 2, 1, 2, 1, 6, 4. What we discussed, same elements, right? So first row, second row, third row columns are printed in a matrix format because we are using /t. So this is /t. After printing one element, tapping is given. Again tapping is given. After one row completed, it go to the next line. /n is used so that it is printed in the matrix format, right? One more case is there. We'll go to the output 2. Enter the number of rows and columns of first matrix, 3, 3. Enter the number of rows and columns of second matrix. This is enter 2, 2. So these are not equal. Row size of first matrix is not equal to second matrix. Similarly, column also not equal. So it is not possible to perform the matrix subtraction. That is displayed. Matrix subtraction is not possible, right? So in this video we discuss how to perform the matrix subtraction. Two cases. If both are equal, the dimension is equal, we can perform the matrix subtraction. We saw one output. The dimensions are not equal, not possible to make the matrix subtraction. The message is displayed in the output 2. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the program to perform matrix multiplication using the C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, matrix multiplication using the C programming language. So this matrix, we need to use the two-dimensional array. We know that array is a collection of same type of data. There are two types available, single dimensional array and two-dimensional array. Single dimensional array is a collection of data. Two-dimensional array is the collection of data having two size available, row size and column size. That is nothing but a matrix. So we need to use the two-dimensional array in order to store the matrix elements. Now we'll see what is the matrix multiplication. We'll see the dimension of the first matrix. So we need to decide some conditions are available. So based on the condition only we can perform the multiplication, matrix multiplication. So let us consider the dimension of the first matrix is m into n. That is number of row is m, number of column is n. Similarly, the dimension of the second matrix is p into q. number of rows is P and number of column is Q, right? What is the condition for this? The M, this N, number of column in the first matrix is equal to number of rows in the second matrix. Then only we can perform the matrix multiplication. That is, these row elements are multiplied with the column elements. Then all are added together, so that these two should be equal. So we'll see the example at the time, you will be able to understand clearly. So the column elements are multiplied with row elements. So these two elements should be equal, right? Suppose n is equal to p, both are equal means we can perform the matrix multiplication. In that case, the resultant matrix after multiplication, what is the dimension of the resultant matrix is nothing but m into q. A row in the first matrix, column in the second matrix. So we will get the resultant matrix is m into q, right? So m into n is the dimension of first matrix, p into q is the dimension of second matrix. N should be equal to p, then only we can perform the matrix multiplication. After multiplication, we got m into q as a resultant matrix, right? Now we'll see the example. Let us consider 2 cross matrix and 3 cross 2 matrix. 2 cross 3 matrix, 2 row 3 columns. Second matrix 3 cross 2, 3 row 2 columns, right? Let us consider this is the matrix A, this is matrix B, having 2 row 3 columns, 1 2 4 6 3 5. Matrix B, 3 row 2 columns, right? 3 5 6 7 1 2. Now this condition is correct, this condition is satisfied. Number of column in the first matrix is 3, number of row in the first matrix is 3, so that we can able to go for multiplication. That is, this 1 is multiplied with 3, 2 is multiplied with 6, 4 is multiplied with 1, then it is added together. So these three elements should be equal to the number of row, number of columns should be equal to number of row, then only we can perform the multiplication. That's why we are checking these 3 should be equal to 3. Number of column in the first matrix should be equal to number of row in the second matrix, right? After multiplication, what is the resultant matrix? 2 cross 2. We'll get the 2 cross 2 as the resultant matrix. Now we'll see the multiplication, right? How to do the multiplication, and we'll verify whether we got the same 2 cross 2 matrix we are able to get, right? We'll see all this. Now consider this A and B. How to multiply this? 1 is multiplied with 3, 1 into 3 plus 2 into 6 plus 4 into 1, right? These 3 column elements are multiplied with these 3 row elements and are added together, right? Suppose in matrix addition and subtraction is easy, 1 plus 3 only we are adding, but here we need to add, or we need to multiply these 3 column elements with 3 row elements and is added together, right? The second, what we are doing, the same, this first row, first this 3 column multiplied with the second column elements, 1 into 5, 2 into 7, 4 into 2, they are all added together, right? Now consider the second, these 3 elements, 6 3 5, the 6 is multiplied with 3, 6 plus 6 into 3, 3 into 6, 5 into 1, all are added together. The same 6 3 5 multiplied with 5 7 2, 6 into 5, 3 into 7, 5 into 2. Now we need to add all these values, right? So 1 into 3 is 3, 2 into 6 12, 4, this 5, 14, 8, 18, 18, 5, 30 is 21 and 10. These 3 are added. 3 plus 12 plus 4, 19, 5 plus 14 plus 8, 27, 18 plus 18 plus 5, 41, 30 plus 21 plus 10, 61. See this, now we got the 2 cross 2 matrix. The resultant matrix is 2 cross 2 matrix. See this 2 cross 2 matrix, we got the resultant matrix, right? So the condition is satisfied. 2 cross 3, 3 cross 2, the 3 equal. So after multiplication we got 2 cross 2 matrix, right? Okay. So then how to frame the expression, equation? We need to frame one expression while doing the program, right? How to do that? C of ij, right? So the A is the first matrix, B is the second matrix, C is the resultant matrix, multiplication matrix. C of ij equal to C of ij. Why we are writing this? We need to add 3 elements. First 3 is added. First 1 and 3 is multiplied, then is added. 2 and 6 is multiplied, that is added with 3. 4 into 1 is multiplied, that is added with this 12. So 3 plus 12 plus 4. 3 times we need to multiply. These 3 results are added together. So C of ij equal to C of ij plus A of I into K. Normally I refers row size, J refers the column size. But here we need one more term. We need to multiply 3 times. So that one more variable is introduced. K. I into Ik into B of K into J. Here we refer the column. 3 column elements. Here we refer the 3 row elements. Right? 1, 2, 3. These 3 column elements are multiplied with row elements. So that here we vary the column as K. Here we vary the row as K. Right? So Ik into Kj. A of Ik into B of Kj. Right? So the K refers column elements. This K refers first one means row elements. These column elements are multiplied with row element. This column element. This is first column element, second column element, third column element. That is multiplied with first row element, second row element, third row element. So that we are multiplying like this. So we can give the expression as C of ij equal to C of ij plus A of Ik into B of Kj. Right? So this ij refers the for loop. We need to open 2-dimensional array. We need to open 2 for loop, outer loop and inner loop. Outer loop vary the row size. Inner loop vary the column size. That we already know that. In that we are additionally introduce one more variable K. Right? So here now we discuss the how to perform the matrix multiplication. What is the process and what is the condition for that. After condition, what is the resultant matrix or the dimension of the resultant matrix and what is the expression. Right? So based on that we can go for the program. So we'll start the program. So the first matrix is M into N dimension. Second matrix dimension is P into Q. Resultant matrix is M into Q. The condition is N equal to P. This N equal to P. Resultant matrix M into Q. Right. Now we'll start the program. First include the header file. Hash include stdio.h. Standard input output header file is used for printf and scanf. Hash include conio.h. Console input output header file used for getch and clear screen. Then void main. We start the main program. Open the brace. First step is we need to declare the variables. What are the variables needed? The A, first matrix. This is a 2-dimensional array. B, second matrix. C, third matrix. We declare with 3-dimensional, 2-dimensional arrays are declared. 10 into 10. Row size is 10, column size is 10. This is a maximum size. We can use within 10. We are normally in this program we are going to use 2 cross 3 matrix and 3 cross 2 matrix. But this is a maximum size. Otherwise we can declare A of 2, 3, B of 3, 2 also. Exactly also we can declare. But if you declare 10, 10, we can use any dimension. According to our requirement we can use. So this is a maximum size. 10 into 10, 100 locations will be allocated. In that we can use our required, that is our choice. Right? So the maximum dimension is declared. This M and N is the dimension of first matrix. PQ dimension of second matrix. In order to open the for loop, we go I, J, K. One more term is available. K is also available. Right. Now we declare the first matrix, second matrix, third matrix, dimension of first matrix, dimension of second matrix, and variable required for loop. Then we can clear the screen in order to clear the previous content. Now we'll get the size of the first matrix and second matrix from the user. Printf, enter the number of rows and columns of first matrix. So the user will enter the 2 values. That is used by scanf %d %d. This refers the integer type. And M and N. Address of M and address of N located in the address. Right? So the user what entered 2 variables stored in M into N. That is row size and column size of the first matrix. Then printf enter the number of rows and columns of second matrix. We ask the user to enter the size of second matrix. So user will enter two data, scan of %d and p and q. First data stored in p, second data stored in q. The row of second matrix, column of second matrix. Right. Now we got this value. Now we'll scan the data. Now we'll get the elements of the first matrix, right? Printf, enter the elements of first matrix for I equal to 0, I less than m, I plus plus. We already discussed that. We are going to use 2 cross 3 matrix. 2 row is 2, column is 3, right? Then and inside this will vary the row, this will vary the column, right? So inside we have one more loop, vary the column, scan of and a of ij, right? First the element what entered, first elements are stored in a. How it will vary? First I equal to 0, I value is 0, right? Then it will go to the condition is correct, it will go to the inner loop. J also 0, this condition is correct, so it will scan the first data stored in 0 0, a of 0 0. First element is stored in a of 0 0. Then j plus plus, j become 1, I is remain 0 only. So the second element stored in 0 1. Then again incremented 2, I is 0. Third element stored in 0 2, right? So while incrementing to 3, it is the condition is false. J less than equal to 3, not less than or equal. Should be less than equal mean 2. So this condition is invalid, right? So it will go, this inner loop is terminated and it will go to the outer loop. Now j become 1. Again I will vary from 0, 1, 2 like that. So the remaining variable stored in 1 0, 1 1, 1 2. Then again it will go to the outer loop 2 0. Then the 2 I will be varied to 2, 2 0, 2 1, 2 2. So the correspondingly the elements are stored in the variable, right? So here only 2 rows are available. This is not invalid. This will be invalid. Okay. Only these 3 elements and these 3 elements. 6 elements are available. When ji equal to 2, the condition is invalid. It will be terminated. Right. So it will be executed 2 times. Right. 0 0 0 1 0 2 1 0 1 1 1 2. If I become 2, the condition is invalid. Right. Now we'll go to the second matrix. Second matrix is the 3 cross 2 matrix. 3 row and 2 column. So we are using PQ, right? This will be 3, this will be 2. So the inner loop will executed 2 times, outer loop executed 3 times, right? 0 0 0 1. Then it will go to 1 0 1 1. Then 2 0 2 1. Like that it will executed, right? I j. First 0 0 0 1. 2 means terminated. Then 1 0 1 1. Then 2 0 2 1, right? So we are having this 3 row and 2 columns, so that corresponding values are stored in B of ij. Now we got the array elements from the user for first matrix as well as second matrix. Now we'll go to the multiplication process. So before going to multiplication, we need to check the condition. If n equal to p, this is the equal operation, equal to operator, whether it will check both are equal. 1 equal mean assignment operator, p will be stored in n. Double equal mean it will check both are equal, right? So if it is equal only, we can proceed for matrix multiplication, right? So before getting the first and second matrix also, we can check this value. After we can check this condition after getting row size and column size of first and second matrix, before getting the elements also. But here we got the elements now, thereafter we are checking. Before getting the elements also we can check. So here the loop is open for I equal to 0, I less than m, I plus plus, j equal to 0, j less than q, j plus plus, right? We already discussed that this m cross n is the first matrix, p cross q is the second matrix. These two should be equal. This is the resultant matrix, right? So the resultant matrix is m into q. So we are using m, we are using q. Then only we get the resultant matrix. Here what we are using, 2 cross 3, 3 cross 2. This condition is true. The output, the resultant will be 2 cross 2. So we are using 2 cross 2, right? The row row size of the first matrix, column size of the second matrix we are using. Then only we will get 2 cross 2 matrix, right? So this is the resultant matrix. Resultant matrix dimension is m into q, that is 2 into q that we are using. Right? We are declare C of ij equal to 0 because we are going to add C of ij cumulatively. In order to get, we need to add 3 variables, right? First column, second column, 3 elements are available. 3 times we need to multiply and add so that it is 0. For k equal to 0, k less than. What is the variable here need? Here 3 is needed, either n or p, because 3 times we are going to do the process, right? Multiplication is done 3 times, 3 variables are added together. How many times we need to multiply? Based on this value, either n or p, right? The column size of the first matrix, row size of the second matrix, that will decide. 3 means here 3 elements available, here also 3 elements available. We need to perform 3 times. So here we are using n, right? The k is used as n, I is the m, this j is q, k may be either n or p, so that we are perform 3 times. So it is very clear, right? The first matrix while read we use m into n. While reading second matrix we use p into q. While doing the matrix multiplication as well as display we need to use m into q. This is the resultant matrix. The inside process multiplication and cumulative addition we can use n or p, right? It is very clearly given. So C of ij equal to C of ij plus A of ik into B of kj. So that automatically the column element, this is row into column element, this is row element. This column element of the first matrix multiplied with row element of the second matrix. Cumulatively it will multiply, then is added together. Initially 0, so 1 by 1 it will add. But in our example we have 3 times we need to do the multiplication. 1 by 1 it will multiply and store in the C, corresponding C, right? First element is C of 0, 0, that is 0, 0. Then it will multiply. Then it will go to 0, 1, 0, 2, like that it will vary. So after this completing this loop, the elements are multiplied. Now we can store, we can display the resultant matrix. The resultant matrix what is multiplied, we need to display, right? Print of the resultant matrix is /n means after printing this line it will go to the next line. For I equal to 0, I less than m, I plus plus. For j equal to 0, j less than q, j plus plus. So resultant matrix also we are using m into q, right? Print of /t. This /t what will happen between the element, it will provide the tapping. After print the first element, some space will be provided, C of ij. So this inner loop will print the entire first row. After printing first row, this loop is terminated, it will go here /n. After printing first row, it will go to the next line, so that we'll get the in a matrix format, right? So the first row printed by using the inner loop with the tapping. So the tapping available between the elements. After that, before going to outer loop, we go /n. So it will go to the next line. Then only it will print the second row. Like that, we'll get in a matrix format. So we close the process. Else, suppose the condition is not correct. The given condition is not correct. We need to print the matrix multiplication is not possible, right? We can print that. Before in this program we got the matrix element, after that we are checking. Before getting the matrix element also we can check, so that we can reduce the process. So get ch and close the program. Get ch mean it will wait for getting the character. Until that we can see the output of the program. Then close the brace. Now we'll see the output. There are 2 cases of output available. One is matrix multiplication possible, another one not possible. We'll see both the output. So the first output is the possible, matrix multiplication possible. Enter the number of row and column of first matrix, 2 into 3. What we discussed in the example, the same size, 2 into 3. Enter the number of rows and columns of second matrix, 3 into 2. These two are equal, so we'll get the 2 cross 2 matrix as a resultant. Enter the elements of first matrix, 1, 2, 4, 6, 3, 5. Enter the elements of second matrix, 3, 5, 6, 7, 1, 2. What we discussed in the example, same elements. So the resultant matrix is 19, 27, 41, 61. But it will display not like that. 19, 27, 41, 61. Because we use the tapping here. And also /n here, so that it will go to the next line, right? It will not print like this. It will print like this in a matrix format, right? First element tapping, second element. Thereafter go to the next line, first element tapping, next element. So it will print in a matrix format, right? So one more possibility is the condition is not correct, right? Enter the number of rows and columns of first matrix. Is not second matrix, the first matrix is 3 cross 3. Enter the number of columns of second matrix, 2 cross 2. Is the condition is not satisfied. These 3 should be equal to 3, right? We are not satisfied, right? 3 cross 3, 2 cross 2. So these two elements are not equal. These two elements should be equal. Then only you can multiply. So we display matrix multiplication is not possible, right? The condition is not satisfied, so that we cannot perform the matrix multiplication, right? So in this program we discuss how to do the matrix multiplication, what is the condition, what is the resultant matrix, what is the process to do the matrix multiplication, and we discuss the program, how to write the coding. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the program to arrange the numbers in ascending order using C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the program. Program to arrange the numbers in ascending order. Ascending order means minimum number to maximum number, minimum value to maximum value. Let us consider these 5 numbers, 8, 3, 6, 9, 5. These 5 numbers will take as an example. We need to arrange in a order from minimum number to maximum number. So the set of number means we need to use the array. Array is the set of same type of same data type. So we can use single dimensional array to store these 5 numbers. Then we can arrange the numbers in a order, right? What is the procedure to arrange the numbers? What is the logic in that? Comparison with first number. Let us consider the first number. This first number is compared with the remaining numbers one by one, right? The step 1 is first number is considered. That first number is compared with the second, third, fourth and fifth number. Now see that first number is compared with the second number. First number is 8, second number is 3. Now second number is lesser. If the second number is lesser, we need to interchange the position. In first position 3 is placed and second position 8 is placed. Number is interchanged. While comparing, the second number is lesser means we can interchange, because our aim is to place the lesser number first, right? So if this number is lesser, so the position is interchanged, right? At first position 3 is placed, second position 8 is placed. Now the first number become 3. This 3 is compared with the third number 6, but 6 is greater, no need to exchange. This 3 is compared with the fourth number 9, that also greater, so no need to exchange. This 3 is compared with the fifth number 5, so this is also greater, so no need to exchange, right? Now first number is compared with all other numbers. In this first case it is lesser, then it is exchanged. Now the number is in the order 3, 8, 6, 9, 5. Earlier 8, 3, 6, 9, 5. Now 3 is 8, 6, 9, 5. See, the first number is arranged in the minimum value, right? What is the next step? The second number should be compared with third, fourth and fifth number. First number is already arranged, right? The second number and third number is compared. The 6 is lesser, right? The 8 is greater and 6 is lesser. Third number is greater. So we need to exchange this number, right? So 6 is placed in second position, 8 is placed in the third position. That is interchange. Now second position, the number become 6. That is compared with the fourth number. Fourth number is 9. It is greater than this number. So no need to exchange. This second number is compared with the fifth number. So this fifth number is lesser. This fifth number is lesser than this number 6. So that also exchanged. Now 5 is placed in the second position, 6 is placed in the fifth position, right? So the second number comparison is over. After that replacement, what we got? 3, 5, 8, 9, 6. See that first minimum number is already placed during the first verification. In the second step, second number is now placed, right? The 3, 5 is placed. Now we need to check the third number with the other numbers. Third number with other numbers. This third position, now we have 8. This is compared with the fourth position number. 8, this is 9. This number is greater, so no need to exchange. Now third number is compared with the fifth number. This is 6. Fifth number is 6. Fifth number 6 is lesser than the 8. So we need to interchange. At third position, 6 is placed. At fifth position, 8 is placed. Right? Now the comparison is over. After the comparison, what we have? 3, 5, 6, 9, 8. See, the first three positions is confirmed. Right? This arranged in a minimum order. Now we need to compare the fourth number. Fourth number with the fifth number. Right? See, this the fifth number is lesser. We need to interchange. So 8 is placed in fourth position. 9 is placed in fifth position. Right? See, for after comparing all these, first number, second number, third number, see this order: 3, 5, 6, 8, 9. Right? Now the numbers are arranged in a order. Right? So the given number, what we are doing, first number compared with the remaining numbers. If the remaining number are lesser, that is placed in the first position. Then second number is compared with the remaining numbers. Lesser mean replace. Then third number, then fourth number. After completing this process, the numbers are arranged in the order. Now we'll go to the program. First will include the header files. Hash include stdio.h, that is standard input output dot header file. This is used for printf and scanf. Then one more header file, hash include conio.h, console input output dot header file. This is used for clear screen and getch. Then we can start the main program. Void main, open the brace. The first step is we need to declare the variables, right? So we need a set of numbers, that is single dimensional array. We can declare the set of number as a single dimensional array, A100. This 100 means maximum we can store 100 numbers. But in example we discuss 5 numbers, right? So less than 100 we can use. The variable name is A, right? A of 100 is a single dimensional array with variable name A. 100 elements, maximum of 100 elements we can store, or we can store lesser also. Then n is the number of elements. How many elements we are going to use. For checking, we have to check the first number with the remaining, so that we need 2 loops are needed. So that is declared by I, j. While using for loop, we need 2 variables. Then we have one temporary variable is available. While exchanging the 2 numbers, the number will be overwritten. So one number is stored in temporary location, then it is exchanged, right? So this A of 100 is the set of numbers. N is how many numbers are there. I and j used for loop. This temporary location we need in temporary variable. So after clear screen, we can go to the coding. First we need to get the total number of elements from the user. Printf, enter the total number of elements, right? How many elements. So the user will enter the number that is scanned by scanf, %d and n. %d refers, this is a integer number, and n means address of n, right? So user what entered total number of elements is stored in n. Now we need to get the elements. What are the elements are available? Then we need to ask the user to enter the number of elements. Printf, enter the array elements. We ask the user to enter the array elements. Number of elements already entered. By using the number of elements, we need to get what are the elements are available that need to enter by the user. For that, we are open the for loop. For I equal to 0, I less than n, I plus plus. So this n we assume that 5, I equal to 5, right? So 5 variable only we discuss in the example. So initially I equal to 0, this condition is correct. So it will scan the first number and store in the variable a of 0. First number is stored in a of 0. Then I plus plus. So I become 1, a of 1, a of 2, a of 3, a of 4. A of 5 means the condition is false, right? I less than, I should be less than means 4. So 0, 1, 2, 3, 4 are valid, 5 means invalid. So that loop will be terminated. The user enter 5 number that are stored in this variable I 0, 1, 2, 3 and 4. A of 0, A of 1, A of 2, A of 3 and A of 4. 5 means loop is terminated. Right. Now we got the elements also, array elements also we received from the user. Now we need to go for the checking of this element. We need to check the element and we need to arrange. That is, first number is checked with the remaining numbers. Then second number is checked with the remaining numbers, like that. So for that we are opening one for loop. For I equal to 0, I less than n, I plus plus. What happened here? This loop will be executed 5 times. 0, 1, 2, 3, like that. Then we'll go to the one more loop, because first number need to verify with remaining numbers, right? So j equal to I plus 1. I equal to 0 mean first number. We need to check with the second number. So I plus 1. I equal to 0 mean j will be 0 plus 1, 1, right? This is first number mean this will be second number. J less than n, j plus plus, right? So I equal to 0 now first number. J equal to 1 second number. So now we are comparing a of I, a of j less than a of I. A of I is the first number, a of j is the second number. Suppose the second number is lesser, we need to interchange. If it is not lesser, no need to interchange, right? The second numbers or third number or fourth number is lesser, we need to interchange, right? We need to interchange a of I and a of j. A of I is temporarily placed in the variable temporary variable. Then a of j is stored in a of I. Now it is overrated. A of j value is placed in a of I. Already what the value available a of I is available in temporary. So we will be overrated. That's why we are storing the a of I in the temporary location. Now a of I value available in temporary location, that will be stored in a of j, right? So our aim is to arrange the a of I as well as a of j. While replacing, it will be overrated. A of j value, second number placed in first position. But first position number will be overrated. That's why before doing this expression, first element is stored in temporary location. From temporary location, it is stored in second position. Now, first number and second numbers are interchanged. When only if the second number is less than the first number. Otherwise, this process will not happen, right? So this is for loop, this is for inner, this is for if loop, if condition. This brace for inner for loop, this is for outer for loop, right? Now we assume that I equal to 0, j is 1, right? First number and second number is compared. Now I remain 0, j become 2, the j plus plus, j become 2. Now first number compared with the third number. If it is lesser, it will be processed, right? Like that it will go 3, 4, right? If it is 5, terminated, because the n value is 5 only, right? It will be ij should be less than 5. If it is equal to 5, that the process is terminated. That is, first number is verified with second number, third number, fourth number and fifth number. In all the cases, the remaining numbers are lesser, mean the process will be interchanged, right? After that, this inner loop will be terminated. It will go to outer loop. Now I become 1. I 1 mean automatically j is 2. I is 1 means I plus 1. 1 plus 1, j equal to 2. That is, second number is compared with third number, fourth number and fifth number. I remain 1. Fifth 5 means terminated, right? Second number compared with the third, fourth and fifth. So if the condition is correct, it will be interchanged, right? Like that it will process all 5 stages. First number, second number, third number and fourth number. Only if the condition is true, that will be interchanged. Otherwise, terminated, right? So after completing this all loop, the numbers are arranged in a order. That we already discussed with the example, how the numbers are arranged. Now we can print the numbers. Print of ascending order is /n mean after printing ascending order, it will go to the next line. So printing also we need to open the for loop. For I equal to 0, I less than n, I plus plus. I is 0, the n is 5. So it will execute it 5 times. 0, 1, 2, 3, 4. So it will print the line, they print the numbers. /t refers the tapping will be provided. In between two numbers, tapping will be given. So it will print a of 0 with and then tapping, a of 1 tapping, a of 2, 3, 4. A of 4 is the first, last number. With the tapping it will print. Then the for loop is closed. After get ch we can close the program. Get ch will get the character from the user. Until that the program will display the output so that we can view the output. After viewing the output, if we enter the character, it will get the character and terminate the program. Now we will see the output. What is the output of this program? See the output. Enter the total number of elements. We ask the user to enter the total number of elements. The user enters 5. Already we discussed 5 numbers only. So this will take 5. Now enter the array element. We ask the user to enter the array element. What we discussed, same set of numbers 8, 3, 6, 9, 5. Right. So after that we are arranged the coding is running. So due to the if condition and for loop, the numbers are arranged. So ascending order is. So it will go to the next line. After printing ascending order is go to next line because of /n. Then 3. And between two numbers the tapping is there. /t is given for this spacing. Between 3 and 5 tapping. Similarly tapping available between the numbers 3, 5, 6, 8 and 9. Now the numbers are arranged in a order. Right. So in this program we discuss how to arrange the numbers in a ascending order. Minimum number to maximum number. First the numbers we need to store in a array. Single dimensional array. The logic is first number is compared with remaining numbers. Remaining number is lesser, position is interchange. Then second number is compared with remaining. Similarly third number, fourth number. Like that we are comparing. While comparing it is lesser means interchange. So that the numbers are arranged in a ascending order, minimum to maximum. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the program to arrange the numbers in descending order using C programming language. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Program to arrange the numbers in descending order. The descending order means maximum number to minimum number. So in order to store the set of data, we need a single dimensional array. So array is nothing but a collection of same type of data. So we need to arrange the numbers. So we need to use single dimensional array. In that the numbers are stored. That numbers we need to arrange in a descending order. Maximum number to minimum number. Right. Now we'll see how to arrange. What is the logic behind that? Arranging of numbers from maximum to minimum descending order. Let us consider these numbers 8, 3, 6, 9 and 5. These are already available in the single dimensional array in this order. This number we need to arrange in a maximum to minimum. So the comparison with the first number 8, 3, 6, 9, 5 is there. First take the first number. The first number is compared with second number, third number, fourth number and fifth number. Right. So the first number is 8. So it is compared with the second number. Suppose the second number is maximum. We need to interchange because what we need is first maximum number. Suppose the second number is not maximum. Suppose minimum is no need to exchange. So here second number is 3 only. First number is 8. No need to exchange. Suppose the second number is maximum. We need to exchange. Then the first number is compared with the third number. So third number also minimum. Less than this 8. This 6 is less than 8. No need to exchange. Now the first number is compared with the fourth number. See this fourth number is 9. It's greater than the first number. What we need is maximum number at the first. So we need to interchange. The fourth number is placed in first position. First number is placed in fourth position. Interchange. After interchange it is like this 9, 3, 6, 8. This 8 is placed here. This 9 is placed in the first position. Then 5. Right. So first number and fourth number is interchanged because fourth number is greater than the first number. Now again first number is check with the Fifth number is lesser, so no need to exchange. So after comparing the first number with the remaining numbers, now the order is changed. 9, 3, 6, 8, 5. Earlier 8, 3, 6, 9, 5. Now 9, 3, 6, 8, 5. Right? So the first set of comparison is completed. First number with remaining numbers. Now we need to check the second number with the remaining numbers. Second number is now 3. 3 is verified with the third number. Third number is 6. This number is greater. The 6 is greater than the second number. So we need to interchange. Right? 6 is placed in second position. 3 is placed in the third position. So it becomes 9, 6, 3, 8, 5. Now again second number. Now this 6 is the second number. Second number is verified with the fourth number. This fourth number also greater. So it is interchanged. Fourth number is greater than the second number. So it is interchanged. 8 is placed in second position. 6 is placed in fourth position. Right now it becomes 9, 8, 3, 6, 5. Again the second number. Now the 8 is the second number. Is verified with the fifth number. Fifth number is lesser. So no need to interchange. Fifth number is less than the second number. So after verifying the second number with the remaining number, the order is now 9, 8, 3, 6, 5. Now we need to go to the third number. Now we need to check third number with the remaining numbers. I will see how to check the third number with the remaining numbers. So the third number is 3. 3 is verified with the fourth number, 6. So fourth number is greater. So we need to interchange. Fourth number is greater than the third number. So we need to interchange. 6 is placed in third position. 3 is placed in fourth position. After that we got 9, 8, 6, 3, 5. Now the third number. Now 6 is the third number. That is verified with the fifth number. Fifth number is lesser. No need to interchange. So what is the order after verifying third number with the remaining numbers? 9, 8, 6, 3, 5. Right. Now we need to check the fourth number with the fifth number. Fourth number and fifth number. Fifth number is greater than the fourth number. Now we need to interchange. 5 is placed in fourth position. 3 is placed in third position, fifth position. So after that what we have? 9, 8, 6, 5, 3. See, this is arranged in a descending order. Maximum number to minimum number. Right. So after comparing all this process, we got with the numbers are arranged in the descending order. Maximum to minimum. Right. So we need to use this process logic inside the program. These numbers are stored in an array. For example, if you take A as a array name, means it is stored in A of 0, A of 1, A of 2, A of 3, A of 4. Now we'll see the program. First include the header file. Hash include stdio.h. Standard input output dot header file. It is used for printf and scanf. Hash include conio.h. Console input output dot header file. It is used for getch and clear screen. Now start the main program. Void main. Open the brace. First step is we need to declare the variable. Our required variable should be declared. The first is A of 100. A of 100 is a single dimensional array. We can store maximum of 100 numbers in this array. Array name is A. The size is 100. Right? But in this program we will use 5 numbers. What we discussed in the comparison, we will use 5 numbers. But we can use up to 100 number also. This is number of elements. Now we are using n equal to 5. So this is a general program. 5 number we will use that, but you can use up to 100 number also. In order to verify, we need for loop. 2 loops are needed. So we are using I and j used for loop. While interchanging the number, we need one temporary variable. While interchanging, the variable is overwritten. So that first variable is stored in the temporary location. After that replaced. Then from temporary location we can recover the first number. So it is used for temporary location. Then clear the screen. Right? We can clear the previous content. Then we'll go to the program. First we'll get the enter the number of element. We ask the user to how many number of element we are going to use. Printf enter the number of elements. Scanf %d and n. And %d refers the integer type and n means address of n. The number what is entered by the user is stored in the variable n. Now we got the n value. Now we need to get the array elements. What are the numbers? Right, let us consider we enter 5 numbers. Now we'll get the 5 numbers here one by one. Printf enter the array elements. Right. So array elements we can store in a array, so that we need to use a for loop. For I equal to 0, I less than n, I plus plus. Let us consider n equal to 5. Right. So first I equal to 0 value. I value is 0. Then it will scan %d and a of I. So the user what entered the first number will store in a of 0. Then I become 1, incremented I plus plus. Second number will store in a of 1. Then a of 2, a of 3, a of 4. Right. Then 5. 5 means invalid. It is less than 5. I is less than 5. Less than or equal to mean okay, here is less than 5. Right. So 0, 1, 2, 3, 4. 5 elements are stored in this array. A of 0, A of 1, A of 2, A of 3 and A of 4. Right. Now we got the array element also. Now we can go for the comparison. First number is compared with second number, third number. Like that we can go for the comparison process. For I equal to 0, I less than n, I plus plus. So we open one I for loop, outer loop. Inside we have open one more loop, because first number need to verify with the second, third, fourth and fifth numbers. Right. So here j equal to I plus 1. I plus 1. So that I equal to 0 means j will be 1. This is first number means j will be second number. So I equal to 0. So j is what is that? 0 plus 1 means 1. Right. So I equal to 0 refers first number. J is 0 refers second number. So we can compare first number with second number. So that j equal to I plus 1. J less than n, j plus plus. Here n equal to 5. Here also n equal to 5. Right. Now now we are checking the variable. If a of I less than a of j. A of I means first number. A of j means second number. Right. You are checking first number and second number. Suppose the second number is greater, because we need a maximum number at the first descending order. If the second number is greater, what we need to do? We need to interchange. The a of j is stored in a of I. Second number is placed in first number. So while doing this expression, the content of first number is overwritten. So before storing the second number into first number is stored in the temporary location. This first number is now placed in the temporary location. Thereafter, second number is placed in first number. Now it is overwritten. But first number available in the temporary location, that is stored in the second number. Right. So we need to interchange second number and first number. Because of overwriting, first number is stored in temporary location. Second number is stored in first number. The first number what is available temporary location will store in second number. Both are interchanged. Right. Now j will be incremented. Incremented means 2. So the first number will be verified with third number. If the condition is true, exchange. Otherwise it will not exchange. Then j is incremented 3. So first number is compared with third number. If the condition is correct, it will be interchange. Otherwise it will leave. Then 4. 4 means first number with fifth number. Right. Then 5. 5 means the condition is false. So it will terminate the inner loop. That will go to the outer loop. Outer loop, what happened? I plus plus. I plus plus means 1. Right. If a j equal to I plus 1. I is already 1. 1 plus 1 means 2. Right. So j is 1. I is 2. That is 1 means second number. J is 2 means third number. Now second number is verified with third number. So it will go 3, 4. Right. 5 will not be there. So second number will be verified with third number, fourth number and fifth number. So like that it will go. It will go up to fifth number, up to 4 times. Right. Fourth number is verified with fifth number. So this process will completed All the, if the condition is true, the variables are interchanged, right? Then now after completing this entire loop and if condition, the numbers are arranged in a ascending order. That we can go for a print. We can print the variables. Print of descending order is /n refers, it will go to the next line. After printing descending order is in, it will go to the next line. For I equal to 0, I less than n, I plus plus. While scanf also we use the same, processing also use the same. Printf /d, integer variable, /t, what is that? After printing the first variable, some tapping will be given. A of I means first 0. It will print 0, A of 0, A of 1, A of 2, A of 3 and A of 4. 5 numbers are printed. In between tapping is there. Then close the for loop. Get ch, it is used to get the character from the user. Until that we can view the output. Then close the program. Right. Now we'll see the sample output. What is the output of this program? Enter the number of element is 5. What we discussed in the example, same 5. Enter the array elements 8, 3, 6, 9, 5. These numbers also same what we discussed earlier. So after executing the program, the numbers are arranged in order 9, 8, 6, 5, 3 from maximum to minimum. So in this program we discuss how to arrange the numbers in descending order, maximum to minimum number. The numbers are stored in a array, single dimensional array. Then we are checking the first number with remaining numbers. If the remaining number are greater, interchange. Then second number is verified with the third and fourth, fifth number. If the remaining number are greater, interchange. Like that we are doing the process. So finally the numbers are arranged in the descending order, maximum to minimum. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we'll see the program to find maximum element in the array using C programming language. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, maximum element in the array. We know that array is a collection of same type of data. Here we are using single dimensional array to store the set of data. In this we need to find what is the maximum element. In this given array element, which one is maximum? That is the program. First we will start the program. First we will include the header file. Has include stdio.h, standard input output header file. This is used for printf and scanf. Has include conio.h, console input output header file. It is used for clear screen and get ch. Then we can start the main program, void main, open the brace. The first step is we need to declare the variables. The first one is integer a of 100. So this is a single dimensional array. Array name is a and maximum size is 100. So we can store 100 numbers in this array. Then n is the how many number we are going to use. Right? This is a maximum number. In that n is how many number. We can use either 5 number or 10 number. For single dimensional array we need a for loop is needed. For that we declare the variable I. So this max is nothing but a maximum element. We are going to store the maximum element in this variable max. Then after clear screen, printf enter the number of element in the array. We ask the user to how many number of element we are going to use. Scanf %d and n. %d refers integer type and n refers address of n. So the user will enter the number of element that will be stored in n. Now we need to get the array elements. Now we got the array. What is the array size? Now we need to get the array element. Printf enter the array elements. We ask the user to enter the array elements. For that we need to open for loop. For I equal to 0, I less than n, I plus plus. Let us consider the n is 5. That is 5 numbers we are going to use. So initially I value is 0. So scanf %d integer type and address of a of I, that is a of 0. The user what entered the first number will be stored in a of 0. Then it will go to the increment. I become 1. So the second number will be stored in A of 1. Like that it will go A of 2, A of 3, A of 4. If it is A of 5, the condition is false. I should be less than 5. Right? The n what we assumed as 5. So if it is I should be less than 5. So it will execute it 5 times. 0, 1, 2, 3, 4. First number stored in A of 0, A of 1, A of 2, A of 3 and A of 4. Then it will terminate it. Right. Next what we are doing, max equal to A of 0. That is A of 0 is the first element. We are make the first element as a maximum. We assume that A of 0, the number first element, the element what we entered first is stored in max. Right? Thereafter we will check with the other numbers. If the other number is maximum, we will replace. Initially first number is stored as a maximum. Now we'll go for the comparison. So in order to verify with other numbers, we open one for loop for I equal to 1, I less than n, I plus plus. We already assume that the n value is 5. Right. So it will initially the I is 1 because already the first number is stored as a maximum. So we'll start with the second number, I of I equal to 1. Right. Normally I starts with 0, but 0 is already assigned as a maximum. So we need to check from second number onwards. So that I start from 1. Right. So here what we are checking, this I equal to 1 means second number. Right. Now A of I is equal to 1. 1 means second number. If A of I greater than max, that is first number already stored in max, this is the second number. Suppose the second number is greater. Second number is greater than this max. Then we need to store this second number as a maximum. Suppose second number is not maximum, it will go to the next step. Right. So the first number already stored here. We are checking with the second number. If the second number is greater, the second number will be stored as a maximum, overwritten. Then it will go to the next process. If it is, this condition is not true, this A of I is not greater than max, then it will not go to this step, it will go to the increment, go to the next step of the for loop. Right. So it will go to the similarly next 2. A of 2 means third number and max will be verified. If it is true, third number will be stored, otherwise it will go to the next loop. So then let go to 3. 3 means fourth number is verified. Then 4 means fifth number. If I equal to 5 means terminated because I less than 5. Right. So max is verified with second number, third number, fourth number, fifth number. If the condition is true, the corresponding number will be stored as a maximum, otherwise it will go to the next step. Right. So finally after executing this loop, the maximum number will be available in this variable max that we can print. Print of the maximum element in the array is %d, that is integer type max. Right. That will be printed. After get cgauge, we can close the program. Get cgauge will get the character from the user. Until that we can see this output. Now we'll see the output. What is the output of this program? Enter number of element in the array 5. We enter 5. Now enter array elements. We ask the user to enter 5 elements: 10, 23, 18, 48, 56. Right. So the maximum element in the array is 56. What is the process? First this 10 is stored in the max. Then 10 is verified with 23. Now 23 is maximum, greater than 10. So the 23 will be stored. This 23 is verified with the 18, but 18 is not greater. So it will not store, it will go to the next step. Then it will check with the 48. This 48 is greater than this 23. Now 48 is stored as a maximum. Right. Now the maximum variable maximum is 48. Then it will check with the fifth number. So this is greater. 48, this 56 is greater than 48. So the 56 stored in the variable maximum. Finally we got the maximum value is 56. Right. So in this program we analyze the maximum element in the given array. The set of numbers, we identify which one is maximum. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the program to search an element in the array using the C programming language. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the program. Searching a element in the array. We know that array is a collection of same type of data. Here we are using single dimensional array, set of data. In that we are going to search a particular element, whether that element is available in the array. Now we'll go to the program. First we'll include the header file, has include stdio.h, standard input output dot header file is used for printf and scanf. Then has include conio.h, console input output dot header file. It is used for clear screen and get ch. Now we can start the main program. Void main, open the brace. The first step is we need to declare the variables. The required variables we need to declare. The first one is a of 100. This is nothing but a single dimensional array. Array name is a. The maximum size of the array element is 100. We can store 100 element in this, but we can use less than that. Maximum we can store 100. So n is the number of elements. How many elements we are going to use. So for a single dimensional array we need one for loop. For that we declare this variable I. So the search, the variable search is nothing but the variable we are going to search in the program, that is stored in search. If the variable is variable available in the array, then we have one more variable found. We'll make it as found equal to 1. So we have one more variable found that will decide whether the variable is available or not, right? So the single dimensional array with 100 elements, number of elements is used for loop. I used for loop. The search contain the element to be searched. The found will be assigned. Found will be give the detail whether the number is found or not. Then clear screen. We clear the previous content. Then the first is printf enter total number of elements. Now we ask the user to enter the total number of elements. Scanf %d and n. This %d refers integer type, and n means address of n. The number what entered by the user will stored in the address of n. Now we got the total number of elements. Now we'll get the elements one by one. For that we need to open one for loop. So now we ask the user to enter the array elements. Now total number enter, now array elements. For that we are using for loop. For I equal to 0, I less than n, I plus plus. Scanf %d and a of I. The element what we entered by the user entered the first element will be stored in a of I. I is 0, right? So the I value is 0 first. Then the first value will be stored in a of 0, address of a of 0. Then incremented to 1. Second variable stored in a of 1. Then it will go to 2, 3, like that it will go, right? Let us consider we have the 10 elements are available. We'll enter 10 elements. So it will go up to 9. If it is 10, it will stop. The loop will be terminated. So it start from 0 to 9 means 10 elements, right? So first element stored in a of 0, then a of 1, a of 2, a of 3 up to a of 9, right? So now 10 elements are stored in this array. Now we can get the printf enter the element to search. We ask the user to which element you are going to search, right? Scanf %d and search. The element to be searched is stored in the variable name search, right? %d refers the integer type, right? So now first we got the total number of elements, then array elements, then element to be searched. All the inputs are now available. Now we can go for checking whether the searched element is available in the array. We have one more element found, that is equal to 0. We assign found equal to 0. If the element is available in the array, we'll make it as found equal to 1, right? So found equal to 1 means array element is available. Found is 0, default. By default found is 0 means after searching also found equal to 0 means the element is not available. If it is available, we'll make found equal to 1. Now we'll go for the searching process. For I equal to 0, I less than n, I plus plus. Again we open the loop because we need to check 10 elements, right? If a of I double equal to search, that is what is the meaning is equal to, whether a of I is equal to search. The search is nothing but the element to be searched, that is used by the enter. Is a of 0, I means first 0. So the first element will be verified with the search whether both are equal. Suppose both are equal means found equal to 1. Already found is 0. If it is equal, we'll make it into 1. Thereafter, no need to check. We can break the process because the searched element is identified. We can break the process. Suppose if it is not equal, the search element and first element is different means it will, this condition is false, it will go to the next, it will go to the outer loop. The incremented, the loop will be incremented, I plus plus. So I become 1. 1 means second element. It will check the second element with the search element. So they are also not found means it will go to the next increment, I plus plus, I3. 2 plus 1 plus 1, 2, third element. So it will check the elements one by one. First it will check A of 0, A of 1, A of 2 up to A of 9. When it is with the, if it is equal, both are equal, then we'll make the found equal to 1 and break the process. That will break the process. Both the for loop and the if condition will be breaked, right? After completing this process, after completing this, we need to check. Initially we put found equal to 0. If found equal to 1 means the searched element is available. So by checking the found value, we can easily identify whether the element is available or not. If found equal to 1, double equal to 1, mean what is the meaning? So here found, when the found become 1, both are equal. Then percentage printf /n %d is found at the position %d, right? This %d is the search element. This %d is position, right? I plus 1. For example, in the third position means A of 2 because I starts from 0, 0, 1, 2, 3, right? A of 3 means fourth position, right? So 3 plus 1, we need to add 1 because I start from 0. I of 3 means fourth element, I of 4 means fifth element, right? We need to add 1, right? So the search, this is the number is found at position. This position number also given by the I plus 1. Else, suppose the found is not equal to 1, else printf %d is not found in the array, right? So by checking found variable, found is 1 means available, found is not is 0 means is not available, right? By checking this found variable, we can easily identify. Now we'll see the output. We'll see the two sample output of this program. So see the first output, output 1. Enter total number of elements is entered by 10. So the total number of elements is 10. Then we ask the user to enter the array elements. These 10 elements are entered one by one. 21, 12, 20, 30, 41, 6, 8, 126, 5 and 100. The 10 array elements are entered. Now we ask the user to enter the element to search is entered by 30, right? So the number of element is 10. All these 10 elements are entered. The element to be searched is 30. See that 30 is available here in this fourth position. So this 30 is verified with the first position, second, third, fourth, like that it will check one by one. So at the fourth position it is available. So it will make found equal to 1 and break the process. After fourth position it will break the process. So it will check found equal to 1. So that 30, this element 30 is found at position 4, I plus 1. Already told I start from 0. Fourth position mean I will be 0. This is 0, 1, 2, 3. I will be 3. I plus 1 means 4, right? So it will give the output, the position. The 30 is available at the found at the position 4. Now we'll go to the one more output, output 2. Enter the total number of elements is 10. Enter the array elements. Same as previous, 21, 12, 20, 30, 41, 6, 8, 125, 5 and 100. But the element to be searched is 50. Earlier 30, it is 50. See, this 50 is not available. So it will check the numbers one by one. 50 is verified with 21, 12, everything. But it is not equal. So the entire loop, it will execute 10 times and it will, that loop is terminated. Already we have found equal to 0. It will be maintained as it is. Found will not become 1. If the elements are equal, then only found equal to 1. So found will be 0. So that 50 is not found in the array. While checking, if found equal to double equal to 1, it is gives 0 only. So it will go to the else part. It will print 50 is not found in the array. So in this program, we verified the given element is available in the array by using the single dimensional array, right? By using the for loop, we verified one by one. We have the logic. Already we have one variable found, that is equal to 0. If the variable is available inside, then we make found equal to 1. So found equal to 0 means not available. Found equal to 1 means it is available in the array. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.